This is a problem on linear model building, and what we have is a set of data points where a pediatrician wants to find a linear model that relates a child's height to head circumference. So height is the y variable and head circumference is the x variable. So we need a model of the form height equals m times circumference plus b. Now that is a typical linear model. So we should often verify the data if it is, linear to begin with. So first we'll enter the data in a calculator. So let's press start and go to number 1, and you would see two lists. I'm going to enter the data in. So I have entered all values in the first list. Now I have to go over to the second list and enter the circumference. So I have 16.4, 16.9, 17.6, 17.3, 17.5, 17.3, 17.5, and 17.5. So first we've got to verify if it is linear using a scatter diagram. So I would press second, y equals, that would bring me stat plots, selecting 1. Then I will turn it on by pressing enter over there. Then I would go to the type of plot, that is scatter plot. So automatically we'll see the x list and the y list. In our case, we put height in the first list, but height is our y variable, so we've got to switch the lists. So I am going to use list 2 as my x variable, because the head circumference is in list 2, second 2, and list 1 is my y variable, so second 1. Once you're done, you exit by doing second mode. Then you go over to zoom and select zoom start, number 9, and that is our graph. Now this is the plot of the points that we have. It's always best to delete any functions that we have in y equals, because it usually causes problems. But when you look at this, it sort of looks linear, so we can say that there is a linear relationship between height and the circumference. Now to get the model, press start, go over to calc and select number 4, which stands for linreg, which is linear regression it fits a linear model for us. And linreg, you've got to specify the x variable first, followed by the y variable. In our case, the x variable is in list 2 and the y variable is in list 1, so I'm going to say list 2 comma list 1. Now press enter. We have our model. So our model is height equals 2.1497 times circumference plus b, which is negative 10.52. So h is equal to 2.15 c minus 10.52. I've just called height as h and circumference as c. So that is our linear model. Next, we've got to interpret the slope. Now, the slope is 2.15. So what does it mean? So for every 1 inch increase in the circumference, the height should change. And how does it change? So for instance, if the circumference is 16 minus 10.52, we will have 2.15 times 16 minus 10.52. I get 23.88. So if we increased it by 1 inch, the circumference increases by 1 inch. Now what happens to the height? The height would become 2.15, 17 minus 10.52. So 2.15 times 17 minus 10.52. So we get 26.03. Let's subtract the two values. 26.03 minus 23.88. I get 2.15. So the difference in the height is 2.15, which is nothing but the slope. So for a unit change in circumference, that is by 1 inch, the height changes by 2.15 inches, and that would be the interpretation of the slope. If we want to predict the circumference, child that is 26 inches tall, we have to reverse the equation, because our linear equation states h is equal to 2.15 c minus 10.52. But if we want to predict the circumference, we would end up having an equation of the form c is equal to m times h plus b. So we need to fit a new model for this. So we could go back to start. We are switching the variables now. So the y variable is the circumference, which is in list 2, and the height variable is height, which is in list 1. So we just simply say second 1, comma second 2. Previously we had it the other way around, so we end up getting c to be equal to 0.3733 plus 7.3, excuse me, that is h times 0.3733 plus 7.33. So that would be a new model. So if we want to predict the head circumference of a child that is 26 inches tall, then C would be 26 times 0.3733 plus 7.33. So we would have 26 times 0.3733 plus 7.33. Enter. We get 17.0358. But if you look at part E, we are looking for the height of the child whose head circumference is 17.4 inches. Now this would correspond to our first model that we fit up here. So we've got to use height equals 2.15c minus 10.52, which would be 2.15 times the circumference is 17.4 minus 10.52. So when we plug that in, we get 2.15 times 17.4 minus 10.52. The answer happens to be 26.89 inches. So the key thing to understand here is what is the y variable and what is the x variable. In the first model, up here, the y variable is h, height, x variable is c, circumference. But in the model in part D, the y variable is c and the x variable is h. Depending on what your x and y variables are, you've got to plug them appropriately in the list. So you've got to keep in mind the calculator always treats the first list as x1, as x, and the second list as y. So by default, whatever you enter in list 1 would be the x variable values, and whatever you enter in list 2 would be the y variable values. So be very careful in what you're entering in each of the lists, because if you switch the lists, then you'd be getting the wrong model.